Our next SAT, Fast 5, is going to discuss complex numbers and the complex number system and solutions that are complex. So first, let's remember a complex number is in the form a plus bi, where a is the real component, the real number component, and bi is the imaginary component. So the whole history on complex number systems. You can get into that on another video, but this is just a quick rundown here. So a couple of things to remember. I is the notation they use to replace the square root of -1. So if I think about squaring both sides of this equal statement, I squared would be -1. So we had some problems in Algebra 2 where we had to do various operations on complex numbers. Sometimes we had solutions that were complex numbers. So let's take a look at some SAT examples here. And I don't know if it's blurry or what, but I think they're using T here instead of I, but that bothers me, so I'm just going to go and make these all I's. So it says, what is the sum of these two complex numbers? So sum means to add them together, and this is a really easy question. You just add the real parts and you add the complex parts. So our real parts of 2 and 4 added together would be a 6, so I think I'm done. I could have just finished the question though, guys. 3i plus 8i would be 11i. So that's why the answer is most definitely 6 plus 11i. Now this was on the non-calculator portion of the test. Some of you are very dependent on your calculator and turning things to complex mode on your calculator. Not going to be an option for you on this question, so make sure you know what I represents and how you work with complex numbers. This question is kind of interesting. So it says in the equation above, t is some constant, and the equation has no real solutions. So which of the following could be the value of t? Alright, so we have a quadratic, and this is, some number. So the first thing I'm going to do is I'm going to subtract t over, and I'm going to call it 2x squared minus 4x minus t is my function. And, alright, so all of these answers here are options for t. So like right here, if I want to plug in a -3, I would get the quadratic 2x squared minus 4x minus -3 will be a plus 3. And I don't remember if this was on the graphing section or not. If it was, you could just graph this and see what the quadratic looks like. If the quadratic looks like this, or like this, that means you have no real solutions because they're imaginary. They're not going to cross the x-axis. If I'm going to assume this was on the no calculator portion of the test, then you'd either have to solve it, or really you only have to find what's called the discriminant. Remember in the quadratic formula, the discriminant is this part of the quadratic formula, the part that's underneath the radical. So that's the b squared minus 4ac part. So if I assume that this is really the equation, and I calculate b squared minus 4ac, I will get, let's see, -4 squared will be 16 minus 4 times a times c, and that is a negative value, because if you think about taking the square root of a negative value, that would give you imaginary numbers, right? So that's actually my answer. I kind of lucked out there with my guessing. Again, if it was a graphing calculator style question and you had a graphing calculator, yeah, you should most definitely use it. That would be might not be the quickest way, but it's the less stressful way, right? Because you can always mess up a formula, but you probably aren't going to mess up typing in your graphing calculator. I will caution you though, look at choice D, the answer of +3. Remember when you subtracted that t over, then it was subtract the t, so that would be a -3, which gives you a very different quadratic. And that was not a mistake on their part that they happened to put both +3 and -3. That was kind of cruel, wasn't it? Alright, hey, 4 minutes. Fast forward today.